Welcome to the Science Science Experience podcast, where we explore the latest and most exciting papers and preprints in science. Before we jump into today's deep dive, please do take a quick second to like, subscribe, and maybe share this with your friends and family. That support really helps the Science Science Experience grow. So today we are diving deep into a new framework. It's called TUMX. That's TUMIX, the tool use mixture. And it feels like it signals a pretty profound shift, actually, in how we might build high-performing AI. We seem to be moving maybe away from this idea of a single monolithic AI genius towards more like a coordinated team of specialists. This framework is all about fundamentally improving how large language models reason, especially when they have to juggle, their internal knowledge alongside powerful external tools, things like code interpreters and search engines.
Yeah, exactly. And what's fascinating here, I think, is that while these modern LLMs have access to incredible tools, they often lack clear guidance on how to deploy them efficiently. It's a real bottleneck. So you give it a question that needs, say, both math and some up-to-date info. Well, the LLM can sometimes experience a kind of analysis paralysis. It might just default to a generalized approach, or maybe run code when it doesn't need to, or search unnecessarily. TMX is really designed to solve that specific failure mode.
Okay, so let's unpack the mechanism a bit. You're saying TMX acts as a kind of ensemble orchestrator. It doesn't just rely on one single reasoning path.
Precisely. It runs multiple diverse agents, and crucially, it runs them in parallel. Each one uses a distinct strategy.
Right. So specialized strategies that not just generic copies of the same LLM.
Exactly. You might have, say, a dedicated code agent. Its starting assumption is this problem probably needs calculation. Then you've got a search agent assuming fresh data is likely the key here. And there are even dual tool agents that are designed to blend those capabilities right from the start.
And the collaboration piece sounds key. These agents aren't just working in isolation, are they?
No, definitely not. They iteratively share their findings and then refine their own responses. They actually use the whole set of answers from the previous round as input for their next try.
Okay, so it ensures a really wide range of solutions gets explored, but efficiently.
That's the idea. And the payoff is real. The paper shows TUNX delivered an average accuracy improvement of up to 3.55% over the best existing methods.
3.55%. Now, that might sound kind of small on paper to some listeners, but when we're talking about frontier models, is that genuinely enough to call it a fundamental change?
Well, I think it is, yeah, because these aren't just random games. They're reliable improvements on really, really hard tasks. This accuracy boost was measured across benchmarks, specifically designed to test complex reasoning. Multi-step problems mixing text, code, search. We're talking about humanities last exam, HLE, GPQA, FIAM, things like. These aren't simple Q&A. They require genuine, orchestrated thought.
Gotcha. So tough problems, consistent gains.
Right. But here's maybe the most surprising finding, the one that sort of pushes back against the simple, bigger is always better idea, the scaling hypothesis. It turns out diversity really trumps scale here.
Okay. How so?
Well, the research showed pretty clearly that a small, diverse group of these specialized agents actually outperformed just running the single best agent over and over again, even many times.
Interesting. So it's not just about brute force repetition.
Exactly. And the tools, like code interpreter and search, they're vital because they drastically increase the diversity of the problem-solving approaches the team can take. They give the agents more distinct ways to tackle the problem.
And didn't they do something clever to sort of maximize that diversity? Something about using LLMs?
Yeah, they did. They introduced this brilliant meta strategy. They actually use other LLMs to automatically optimize the agent designs themselves.
So the AI is basically designing better AI teammates for itself.
Kind of, yeah. It's optimizing the prompts and configurations for these agents. And that clever trick alone delivered an additional average accuracy lift of about 1.2%.
Wow, okay.
But, running all these diverse agents and iterating, that sounds potentially expensive, right? And refinement isn't always good. The research confirmed that too. Sometimes you get over-refinement, where iterating too much actually makes the answer worse, like second-guessing yourself out of the right answer.
Right, analysis paralysis again. So how did they tackle that efficiency problem, the cost of running everything in parallel and iterating?
TMX has this adaptive early termination strategy. It's pretty neat.
Okay.
They basically query another LLM acting as a judge.
Yeah.
This judge looks at the current set of answers from all the agents. It assesses the consistency, the convergence, and decides whether the team has likely reached a good enough answer and can just stop the refinement process early.
So it cuts the process short when it looks like they've nailed it?
Exactly. And this judge step is critical for making it practical. It reduced the overall inference costs by roughly 49%. 49%.
Wow, that's huge.
Yeah, and crucially, it did this while preserving, or in some cases even slightly improving, the peak performance.
So for you, the listener, this means tools like code interpreters or search might become not just more accurate on those tricky multi-step questions, but also significantly faster and cheaper to run.
That's the implication, yeah. Better and cheaper.
So stepping back then, it feels like the evolution of these really advanced models might rely less on that traditional approach, building one single massive monolithic AI, the sort of singular genius model, and maybe much more on building these efficient, diverse teams of specialized agents, agents that really know how to collaborate and coordinate effectively.
Mm-hmm. It's a different architectural philosophy.
Yeah, it kind of reminds me of shifts we've seen elsewhere, like microservices replacing giant mainframe applications and software. It suggests maybe the future of complex AI systems will depend more on robust, specialized collaboration rather than just raw scale alone.
It definitely raises an important question for the future, I think. If collaboration and diversity are proving to be such keys to performance, how should we prioritize training? Do we focus more on specialization versus generalization in the next wave of foundational models? It's a big strategic question.
Definitely something to think about. Well, thank you for joining us on this deep dive into the architecture of TUMIX. Really fascinating stuff. And remember to like and subscribe to stay tuned for the next breakthrough in science right here at the SAN Science Experience.